Hello, Mateen. Let's go over a couple examples of significant digits. It's not too bad once you understand what the principle is. There's different rules for different types of mathematical operations. The first one that we'll cover is multiplication and division. For multiplication and division, the value with the least number of significant digits that are in the question stem, that'll determine the number of significant digits in your answer. So let's take a look at an example. So the first example is we have a mass of 12.2 kilograms and it's accelerating at 5.3 meters per second squared, and we're just trying to figure out what the force is. So if we figure out our answer, and we have an unrounded value right here, to figure out our significant digits we need to look at the numbers that are used in the calculation. If we take a look at 12.2, this has 3 significant digits, 1, 2, 3, and 5.3 has 2 digits, 1, 2. So our answer has to have the same number of significant digits as the number with the least number of significant digits. Since this has 2 sig digs, our answer then has 2 sig digs. 1, 2. The same rules apply for division. We take a look at the questions or the values that are being divided. In this case, this has 4 sig digs. This has 2 sig digs. We get our unrounded value, and then we need to round so that our answer has 2 sig digs, so it's rounded to 3.8 meters per second. The rules for addition are a little bit different. For addition and subtraction, the precision is shown by the number of decimal places. So the more decimal places an answer or a value has, it shows that it's more precise. So if we take a look at this example, we've got these different distances being added. 11.2 has been measured to the 10th. 13.3 has been measured to the 100th, and 15.678, that's been measured to the 1000th. So the least precise measurement is this 11.2 because it only has 1 decimal place, so our answer has to have the same amount of precision, and we round our answer of 40.308 to 40.3 just because these both have a precision to the 10th. The same rules apply to subtraction. We've got this one being measured to the 1000th, the 100th, and the 1000th. Therefore, our answer, this was just the answer. This one right here has been measured to the 100th, so therefore our answer has to be measured to the 100th. We don't want to have an answer to measure to the 1000th when the precision of the values in the calculation has only been to the 100th. It just doesn't make sense. You want to be as precise as your least precise value. The other thing that we need to go over is rules for zeros. The rules for zeros are a little bit different. Zeros appearing anywhere between non-digit values are significant, so these zeros are in between non-zero values, so they count towards sig digs, and therefore this number right here would have 7 sig digs. Leading zeros are not significant, and this is something that messes a lot of students up. Therefore a number like 0.00052 only has 2 sig digs because these zeros, the leading zeros, aren't significant. So this number only has 2 sig digs. Trailing zeros in a number are significant. So if we have something like 12.2300, since these are trailing zeros, they count. And this 12.2300 has 6 significant figures. The other thing that you need to know for this course is a number like 100. This has 3 significant digits. A number like 10 would have 2 significant digits. Some textbooks and some courses say that you need to have a decimal after those values for those trailing zeros to be significant, but that's not the case in this course. I hope that helps you out, and you can contact me in private discussions if you have more questions.